Yeah, good evening, dear Professor Kroemer, dear distinguished guests, dear colleagues, dear students, ladies and gentlemen. On behalf of the Executive Board of the Anatomical Society, it's my great pleasure to welcome you to the 111th meeting of the Anatomical Society. Willkommen zur 111. Jahrestagung der Anatomischen Gesellschaft here in Göttingen. During the pre-conference today, you already got an excellent impression of anatomy and teaching and the exciting perspectives presented by distinguished colleagues and speakers. In the following few days, I'm sure you will also enjoy excellent science covering a broad range of anatomical research, which will be presented both as lectures and posters. A first impression from the science will be conveyed by two young investigators who are recipients of our Young Investigator Awards. In a few minutes, you will see the presentations. This impression will be complemented by this year's recipients of Waldeyer Award, also in a few minutes. It's also my great pleasure to announce the guest lecture of this evening, held by Nick Hopwood from Cambridge, UK. He is going to talk about a very interesting topic entitled Haeckel's Embryos, Images, Evolution, and Fraud. Without taking too much of your valuable time for now, I would like to thank our hosts and the organizers of this meeting, Professor Staiger, Professor Fieban, and Professor Wilting, for the excellent preparation of the teaching, scientific, and environmental program of this meeting. Please enjoy this meeting, but for now, I wish you all a wonderful evening, which will be accompanied by a musical framework presented, as you heard, by the Göttingen Baroque Orchestra. So I'm delighted to hand over the microphone to Professor Kroemer, and the Dean of the Medical Faculty of the University of Göttingen. Professor Kroemer, please.
Professor Ergün, ladies and gentlemen, dear colleagues, I'd like to welcome you here at the Georg August University in Göttingen, and in particular at the medical school. My name is Heyo Kroemer. I'm a pharmacologist by training. I have a close relationship to anatomy because my pharmacological institute at my previous university in Greifswald was directly close to the Institute of the Endlichs, so I had a very close interaction with anatomy during that time. Now here I'm Dean of the Medical Faculty, and I'm chairing the board of the Academic Medical Center. And we are extremely pleased to host the 111th meeting of the Anatomical Society here in Göttingen. You're at a quite traditional university, which was founded in 1737 as a traditional German university, had a topic it was famous for, which was enlightenment, and since 1737 there's a medical school here in Göttingen. So it's close to 280 years now, and the Academic Medical Center of today has dramatically changed compared to the 18th century. We have now 1,450 beds in our hospital, employ about 8,000 people, and see around 65,000 patients a year in an integrative model. So the hospital and the faculty are run together organized together by the same board. We are three people who try to organize this enterprise. We have very strong scientific activities in three areas. We're extremely good in neuroscience, and here in particular in neurodegeneration and myelin disorders, and the neuroscience part is also closely related to activities in our anatomy. We are quite leading in cardiovascular, in particular in heart failure, and in a more developing area in oncology, our scientists address genome stability aspects and certain types of cancer. Overall, the place is very strong due to a close interaction with the Max Planck Society. We have numerous places. Just across the street from our medical center is a Max Planck Institute for Experimental Medicine. So we're very happy to have this interaction. We are, as as well happy about your international meeting of anatomy with more than 350 scientists. You will listen to 74 oral presentation, and you cover a very wide range of topics from vessel development to neurobiology. So since this is the 111th meeting, there must have been 110 meetings out of Göttingen. So you might take your time and look at the city a bit. It's a real science city. People here are proud to have a total of 45 Nobel laureates associated to this university. Most of them are dead, however, but there are three of them quite alive, and two of them have very close interaction with medicine on a day-to-day basis. So I hope that you find some time to not just see the meeting, which is of high interest, but also to look at the city, which is really pleasant to live in. And I wish your meeting very fruitful conversations. And again, thank you for coming to Göttingen. Thank you.
Dear Dean of the Medical Faculty, Professor Kroemer, dear President in Office of the Anatomische Gesellschaft, Professor Ergün, dear colleagues, ladies and gentlemen. Usually people who are standing here are Nobel laureates, and unfortunately just standing here does not qualify you for the Nobel Prize, because otherwise all the recent efforts we put in organizing this conference would pay off very well for me. But I'm standing here on behalf of the organizing committee, which I had the pleasure to lead, and on behalf of this organizing committee and the whole Center of Anatomy of the University Medical School of Göttingen, I welcome you here in Göttingen at this beautiful place of the Aula of the Georg August University. During the last 18 months, we have done our best to put together a conference program that would be exciting scientifically and memorable socially for all of you. This was quite a challenge since the meeting schedule of the Anatomische Gesellschaft was recently changed, and there was as of yet no prediction possible how many colleagues would make it to Göttingen. We expected around 250, but as you've already heard, there will be around 350 registered participants at that meeting. We are confident, however, that there will be enough space, food and drinks for everybody, and also, not so unimportant, enough space for oral and poster sessions to host the science of all of you. In conjunction with numerous excellent keynote speakers, this should suffice to make up a great conference. So once more, welcome to Göttingen. Enjoy the meeting.
So now we move on to the presentation of the Nachwuchspreis of our society. So the Anatomical Society received a high number of excellent applications. So you can imagine it was not so easy to make a selection, but finally we had to make a decision and to select two recipients. First one is for the Promotionspreis, and the recipient of the Promotionspreis is Dr. Maximilian Lenz. Congratulations, Dr. Lenz.
Yeah, dear Dean of the Medical Faculty, dear President, dear Secretary, dear Award Committee, dear colleagues, dear ladies and gentlemen, it's a great honor for me to receive this award, and it's not only an award for me, but for the entire research team with which I'm working now for 6 years. It's a great pleasure for me also to be part of this society. What we investigated in the last years was the cellular mechanisms of repetitive magnetic stimulation-induced plasticity in the brain. It's a non-invasive brain stimulation technique which you can use to stimulate the human brain through the skull, and when you apply these magnetic pulses repetitively, you are able to change the cortical excitability in humans. And to unravel these mechanisms, we used animal models and in vitro stimulations of, in our case, organotypic entorhinal hippocampal slice cultures. What we found out is that a repetitive magnetic stimulation affects both excitatory and inhibitory contacts of neurons, the inhibitory and excitatory synapses. On the one hand, inhibitory synapses were downregulated in its strength, but not overall in all inhibitory circuits. These changes were restricted to a subpopulation of interneuronal circuits, and these neuronal circuits project to the dendrites of CA1 pyramidal cells, whereas the somatic compartment was not affected. On the other hand, the excitatory synapses were strengthened after a stimulation, and also these changes were not detectable overall the dendritic tree of the cells, but was restricted to the proximal dendrites of CA1 cells. So we concluded from this that these changes induced by this unspecific repetitive magnetic stimulation are input specific, so very specialized in neuronal circuits. Therefore, this is our hypothesis that repetitive magnetic stimulation promotes localized changes in neuronal excitation-inhibition balance. And this is of particular interest in those diseases which are accompanied by changes in excitation-inhibition balance. Therefore, we think that RMS may be an interesting tool to restore this altered excitation-inhibition balance, and therefore might be beneficial for the patients suffering from these diseases. I would like to end with special thanks to my supervisor and mentor, Andreas Flachos. He was and is a great mentor for me. Many thanks, Andreas, for all your support during the last years. And I would like to thank also the whole research team in the lab of Thomas Steller, who, since all these experiments were performed in his lab. Many, many thanks.
Damit überreiche ich die Urkunde. Also in Urkunde steht Nachwuchspreis der Anatomischen Gesellschaft 2016, verliehen auf der 111. Jahresversammlung in Göttingen, verliehen an Dr. Maximilian Lenz von Düsseldorf und für die Arbeit Einfluss repetitiver Magnetstimulation auf exzitatorische und inhibitorische Synapsen von Prinzipialneuronen in organotypischen enterorhino-hippocampalen Schnittkulturen der Maus und gezeichnet von dem derzeitigen Präsidenten, also von mir, Süleyman Ergün. Und ja, herzlichen Glückwunsch nochmal. Okay, now we move on to the second prize, and the recipient is Dr. Christoph Wiegreffe from Ulm. Dr. Wiegreffe, please come.
Dear Dean of the Medical Faculty, dear President of the Anatomische Gesellschaft, thank you very much for rewarding me this prize. I hope this will work. Okay. Dear ladies and gentlemen, we found an essential role for the transcriptional regulator BCL11A in neocortical development. And with this next slide, I would like to give you a simplified overview of the complex system that we use so that you will understand my data. Progenitor cells located in the ventricular zone and subventricular zone of the neocortex give rise to postmitotic projection neurons that leave these zones and migrate towards their target into the cortical plate. Early in development, the deep layer neurons are born, and successively the upper layer neurons are generated. During their migration, projection neurons undergo transient morphological changes from a transient multipolar to a bipolar morphology. These complex mechanisms are controlled by cell-extrinsic and cell-intrinsic regulatory mechanisms. We observed that BCL11A is co-expressed in upper neocortical layers with CAX1 and BRN2, suggesting functions of BCL11A in late-born upper layer neocortical projection neurons. To analyze the functions of BCL11A in these cells, we deleted BCL11A by in utero electroporation in conditional mutant mice. BCL11A mutant neurons are stalled along their migratory route in the ventricular, subventricular, and intermediate zones in comparison to control neurons, suggesting defects in neuronal migration. When we looked at the morphology of migrating neurons, we found an increase in the number of multipolar at the expense of bipolar neurons, suggesting defects in polarization. The Golgi apparatus can be used as a measurement for cell polarity in neurons, and when we use this readout to determine cell polarity in BCL11A mutant neurons, we found that the Golgi apparatus was randomized, localized, suggesting defects in polarization. So to directly determine defects in polarization and neuronal migration in BCL11A mutant neurons, we performed time-lapse imaging of neuronal slice cultures, and you can see on the left side a control neuron, and on the right-hand side a BCL11A mutant neuron that fails to properly switch to a bipolar morphology and continue radially oriented migration into the cortical plate. We looked at traces of BCL11A mutant neurons and found that these cells undergo repetitive phases of several hours duration with extremely reduced migration speed and random-like orientation changes. We asked then what are the downstream programs of this transcription factor and performed a differential transcriptome analysis. We identified semaphorin 3C, a classical axon guidance molecule. Using qRT-PCR and in situ hybridization, we found SEMA3C to be upregulated in BCL11A mutant neurons. We identified a regulatory element in the second intron of this gene, which BCL11A binds to and which conveyed transcriptional repression. Finally, we found that BCL11A protein and SEMA3C messenger RNA were co-localized in the upper subventricular and intermediate zones, and together these results suggest that SEMA3C is a transcriptional target of BCL11A. Overexpression of SEMA3C in wild-type neocortices phenocopied the BCL11A mutant phenotype, whereas normalization of SEMA3C by using shRNAs rescued the mutant phenotype. So this suggests that SEMA3C is a major downstream effector of BCL11A in migrating cortical neurons. And I would like to summarize that we identified BCL11A as a novel transcriptional control over cortical neuron migration and polarity that acts through SEMA3C. And I would like to acknowledge the people involved in this work, my boss, who's in the audience, Stefan Britsch, and the other people from the lab in Ulm, as well as Viktor Tarabikin and our other collaborators. And I would like to thank the DFG for funding and the Anatomische Gesellschaft for rewarding me this prize. Thank you very much.
Yeah, congratulations to this very excellent talk. And ja, Ihnen auch nun Ihr Urkunde, Nachwuchspreis der Anatomischen Gesellschaft 2016, verliehen auf der 111. Jahresversammlung in Göttingen an Dr. Reinhard Wiegreffe, Christoph, also Wiegreffe von Ulm für die Arbeit mit dem Titel BCL11A, C-Typ 1, in Klammern, controls migration of cortical projection neurons through regulation of SEMA3C. Congratulations.
Thank you very much.
And, yeah.
Sehr geehrte Frau Kriegelstein, meine Herren des Vorstandes der Anatomischen Gesellschaft, Sie haben mich gebeten, die Laudatio zur Verleihung des Anton-Waldeyer-Preises, den in diesem Jahr Herr Professor Putz erhalten wird, hier in Göttingen zu halten. Und ich begrüße Herrn Professor Putz hier ganz, ganz herzlich. Und ich glaube, das darf ich in Ihrer aller Namen tun. Liebe Kolleginnen und Kollegen, meine Damen und Herren, wollte ich die Ehrungen und Preise, die Herr Professor Putz in seiner akademischen Laufbahn erhalten hat, aufzählen, wäre die mir zugestandene Redezeit damit ausgefüllt. Ich muss mich auf mir wichtig erscheinende Ehrungen beschränken. Er ist Ehrenmitglied zahlreicher nationaler und internationaler wissenschaftlicher Gesellschaften, Mitglied der Deutschen Akademie Naturforscher Leopoldina, Doktor honoris causa der Ovidius-Universität Constanta in Rumänien, Träger des österreichischen Ehrenkreuzes für Wissenschaft und Kunst erster Klasse sowie des Bundesverdienstkreuzes. Eine wichtige Auszeichnung fehlt in der Vita von Reinhard Putz, eine Ehrung durch die Anatomische Gesellschaft, der er 1990 bei der 91. Jahresversammlung in Hamburg vorstand. Diese Lücke wird durch die Verleihung des Anton-Waldeyer-Preises unserer Fachgesellschaft nun geschlossen. Herr Professor Putz erfüllt die Statuten für diesen Preis in, wie ich meine, idealerweise als Forscher, akademischer Lehrer sowie in der positiven Repräsentation unseres Faches in der Öffentlichkeit im In- und im Ausland. Das wissenschaftliche Œuvre umfasst mehr als 250 Originalarbeiten. Der Schwerpunkt seiner wissenschaftlichen Arbeit liegt auf dem Gebiet des Bewegungsapparates und hier speziell bei der Wirbelsäule. Sie sehen hier die Habilitationsarbeit. Ich durfte sie begutachten. Die Fragestellungen sind originell und werden mit auf tiefer Kenntnis der makroskopischen und mikroskopischen Anatomie basierenden Methoden der Biomechanik sowie moderner bildgebender Verfahren beantwortet. So verwundert es nicht, dass sich für seine Forschungen Kollegen unterschiedlicher klinischer Fachrichtungen interessieren und interessierten. In der Satzung zum Waldeyer-Preis steht, dass das Werk des oder der Auszuzeichnenden eine Bedeutung der Anatomie für ärztliches Handeln und die enge Beziehung von Anatomie und Klinik zur Grundlage haben soll. Das erfüllen die Publikationen von Herrn Putz in hohem Maße. Wer eine Reise übrigens mal ins östliche Westfalen machen möchte, vielleicht um das Weltkulturerbe Korvey zu besichtigen, findet nahe bei Höxter das Grab von Anton-Waldeyer und seiner Frau, die übrigens hier, die ich noch in meiner Jugendzeit hier auf unseren Versammlungen gesehen habe. Als Lehrbuchautor ist Reinhard Putz unter anderem als Herausgeber von Atlanten, der Anatomie Wolf Heidegger und Sobotta sehr vielen Kollegen und Kolleginnen bekannt. Er verfasste zahlreiche Lehrbuchartikel für anatomische und klinische Werke. Bemerkenswert finde ich die Anatomie für Kinder, Mein Körper und ich, die er geschrieben hat. Der Eros für seine exzellente Lehre hat familiäre Wurzeln. Herr Putz studierte zunächst Pädagogik und schloss das Studium für das Lehramt ab. Er wurde unter anderem von seiner Universität im Rahmen des München-Harvard-Programms für sein Engagement ausgezeichnet und erhielt den Preis Ars Legendi der Deutschen Rektorenkonferenz. Die Kieler Studierenden lernten 2001 seine kluge Didaktik in einer inhaltlich anspruchsvollen Gastvorlesung kennen. Sie sehen hier Reinhard Putz, den ich durch Schleswig-Holstein geführt habe, um ihm die Kulturgüter unseres Landes zu zeigen, in dem kleinen Fischerort Holm bei Schleswig. Er wunderte sich damals, dass wir echte Stefan Lochners hatten, aber das ist so in Schleswig-Holstein. Für den akademischen Nachwuchs unseres Faches führte er zahlreiche Kurse und Symposien durch. Bis heute engagiert sich Herr Putz für eine zeitgemäße, aber zugleich basisorientierte und zielgerichtete Lehre in unserem Fach. Unser Preisträger wurde 1942 in Innsbruck geboren. Dort ging er zur Schule, dort studierte er nach dem Pädagogikstudium und nach seinem Dienst beim Bundesheer, er ist Oberleutnantarzt der Reserve, Medizin und erhielt 1979 nach der Promotion die Lehrbefugnis als Universitätsdozent für Anatomie. Seiner Heimat fühlt er sich bis heute verbunden. Das Foto unten etwas früheren Zeiten spricht eigentlich für sich. Wenngleich sein zweites Zuhause in Österreich heute eher Kärnten ist. Zur Universität seiner Heimatstadt Innsbruck kehrte er aber 2009 als Mitglied des Universitätsrates zurück und ist es wohl bis heute noch. Von 1982 bis 1989 hatte Herr Putz den Lehrstuhl 3 für Anatomie in Freiburg inne. Von dort wurde er auf den Lehrstuhl nach München berufen, dem er bis 2007 vorstand. Einen Ruf auf die Nachfolge seines Lehrers Werner Platzer nach Innsbruck lehnte er ab. Herr Putz war ungemein aktiv in der akademischen Selbstverwaltung. So diente er unter anderem seiner Universität 2007 als Prorektor und später als Vizepräsident. Meine Damen und Herren, gestatten Sie abschließend ein paar persönliche Worte. Reinhard Putz und ich begegneten uns im Rahmen unserer ersten Gehversuche bei der Anatomischen Gesellschaft. Und wer mich kennt, weiß, dass bei Diskussionen es nicht immer friedlich zuging. Man lernt einen Menschen am besten kennen und schätzen, wenn man zu zweit ein paar Tage fernab aller Zivilisation mit dem Rucksack durch eine wunderschöne Gebirgslandschaft wandert. Das taten wir zwei 1999 auf dem Karnischen Höhenweg. Sie sehen hier einige Bilder davon. Auf dem Bild rechts oben, habe ich hier irgendwo ein, da sehen Sie, wie Herr Putz gerade einen schwarzen Salamander fotografiert. Er hatte die bessere Kamera. Ich habe dieses Bild noch sehr, sehr lange im Unterricht gezeigt, um die Umstellung der Extremitäten in der Vertebratenreihe zu demonstrieren. Wir kamen übrigens von dieser Bergtour als Freunde zurück. Unser Preisträger kennt keineswegs nur die Anatomie. Er ist auch mit Literatur und Kunst jedweder Art vertraut. Wie zahlreiche Fachkollegen ist er ein exzellenter Zeichner. Ich möchte ihn als Künstler bezeichnen. Seine Weihnachtskarten, die Sie hier mal von 14 und 15 sehen, habe ich alle aufbewahrt. Uns verbindet auch die Liebe zur Musik, speziell zum Gesang. Zufällig haben das Ehepaar Putz und ich dieselben Präferenzen, wenn es um die Stimmen von Tenören und Baritonen geht. Mit einem herzlichen Glückwunsch zum Anton-Waldeyer-Preis 2016, verbinde ich sicher auch in Ihrer aller Namen die Hoffnung und den Wunsch, dass Herr Professor Putz unserem Fach noch viele, viele Jahre verbunden bleiben möge. Ad multos annos.
Ja, auch ich freue mich sehr, dass Herr Putz, den ich immer wieder auf den anatomischen Tagungen, Jahresversammlungen, damals hatten wir immer zwei, Würzburg und Jahresversammlung, erleben durfte und auch in persönlichen Gesprächen. Also herzlichen Glückwunsch nochmal an dieser Stelle zu diesem Preis. Und nun die Urkunde, Anton-Waldeyer-Preis der Anatomischen Gesellschaft 2016 und der Anton-Waldeyer-Stiftung verliehen auf der 111. Jahresversammlung in Göttingen an Herrn Professor Dr. Med. Dr. H.C. Reinhard Putz und unterzeichnet von mir als Präsident der Anatomischen Gesellschaft und von Heinrich Waldeyer, Dr. Heinrich Waldeyer. Das ist die Urkunde.
Herr Präsident Ergün, lieber Bernhard, meine Damen und Herren, ich bin etwas gerührt. Ich war sehr überrascht, wie mir die Kunde zugetragen wurde, dass ich diesen Preis erhalten sollte. Und die vielen lobenden Worte von dir, Bernhard, erinnern mich an das bayerische Sprichwort, zu viel Weihrauch macht auch den schönsten Heiligen rosig. Ja, also es ist schwer, sich das alles anzuhören. Paradoxerweise hat dieses Wort klinische Anatomie für mich lange Zeit einen eher negativen Beigeschmack gehabt. Ich bin in einem Umfeld aufgewachsen, das klinische Anatomie als sehr vordergründigen Bereich gewissermaßen als eine Art Andienen an die Klinik gesehen hat, sodass zum Schluss, ich sage das ganz hart und ausdrücklich, wir Anatomen in die Art gehobener technischer Assistentinnen zum Schluss geraten sind und mit dem konnte ich nichts anfangen. Mein allererster Lehrer, Gustav Sauser, hat uns die Anatomie in einer anderen Form dargestellt als den eigentlichen Weg in die gesamte Medizin, hat die Basis für die ganze Medizin aus der Anatomie entwickelt, schön vorsichtig in ihren jeweiligen Stellenwert. Das hat mich viel mehr bewegt. Und so habe ich dann einen Weg für mich gewählt, der mich wissenschaftlich mit Dingen hat befassen lassen, die dann für die Klinik, wenn jemand wollte, Orthopädie, Radiologie, Unfallchirurgie, vielleicht hilfreich und wie ich dann später kennengelernt habe, sogar sehr hilfreich und befruchtend geworden ist. Ich wollte immer Herr meiner eigenen Tätigkeit, meiner Forschungsbereiche werden. Das erste Bild, das Bernhard Tillmann gezeigt hat von meiner Habilitationsarbeit, ist der Schlüssel für mein ganzes weiteres Forschungsleben. Ich habe im Jahr 74, glaube ich, war es, im Handbuch der Gelenke von Rudolf Fick, das war damals unsere Bibel in den 60er Jahren, mich begonnen, ein bisschen über die Wirbelsäule anzulesen und dort steht der Satz, Sie können nachschlagen, die Wirbelgelenke gehören zu den irregulären Gelenken, deren Prinzip in der Ungenauigkeit der Ausführung besteht. Und über einen solchen Satz muss ein denkender junger Mensch irritiert sein und der hat mich zu meiner wissenschaftlichen Fragestellung bewegt und Felix Eckstein wird das bestätigen können und andere auch. Uns hat interessiert in der gesamten Gruppe zu verstehen, warum die Gelenke so ausschauen, wie sie ausschauen. Nach Geometrie, nach Materialverteilung, nach Beanspruchung und so weiter. Und daraus lässt sich am Beispiel der Wirbelgelenke begonnen, unser ganzes Werk, was wir begonnen haben mit vielen Mitarbeiterinnen, Mitarbeitern, einige sitzen hier, dieses ganze Werk eigentlich erklären. Klinische Anatomie ist für mich der Begriff für unser ganzes Fach eigentlich immer gewesen. Die Form-Funktionsanalyse, das ist das, was uns bewegt. Und wenn man von einer irritierenden Form ausgeht, von einem irritierenden Befund, wie Sie es ja alle in den Labors immer wieder erleben, und dann zu einer über eine sinnvolle Methodik, zu einer sinnvoll weiterführenden Analyse und Befunden und Aussagen kommt, das ist das, was das Leben eines Anatomen beglückend macht. Und so habe ich mein ganzes Leben als Anatom empfunden. Und ich danke an dieser Stelle allen, die daran mitgewirkt haben, Mitarbeiter, Mitarbeiterinnen mitgemacht haben, viele Kollegen, mit denen wir uns manchmal etwas gerieben haben, aber uns immer konstruktiv gefunden haben. Vielen herzlichen Dank.
on to the guest lecture of this evening, presented by Dr. Nick Hopwood, but the introductory word will come from Professor Tillmann.
Yeah, thank you very much, dear colleagues. It's a great honor to be able to present our next speaker, Professor Nick Hopwood. And in doing so, I don't want to be too long, but I am afraid I have to mention the N word again that we heard already several times, the Nobel Prize, which is in the air in Göttingen, because I can say that somebody accepted the invitation from me. I know somebody who has worked with a Nobel Prize winner. And the Nobel Prize winner is John Gurdon. We know the work, the cloning that was exemplified by the sheep dolly, and the basis of that work was founded by John Gurdon in 1962 when he transplanted nuclei of a xenopus embryo into another one, into an oocyte, and then clones developed. And that person is very famous. He's alive and still giving very good talks, and he's very critical, and he accepted Nick Hopwood as a molecular biologist student to do his PhD in the 1980s. So our next speaker has got an historical topic, but he is by training a molecular biologist, and a very good one, a brilliant mind that was accepted by somebody who is very critical with his students. And that is important for us because very few people understand our problems that we have with our collections, particularly with our embryology collection, and his Nick's topic is embryology. It's the embryology collections that started with Haeckel and all the problems around the person of Haeckel and the collection and all these embryos. And he very kindly accepted that also will help. He will help us with resolving the history of our collections. And the collections I'm mentioning because this university has made it a special desire to put the collections in front in their attempt to be excellent, to have the excellence initiative, to win the excellence initiative in the next round again. And so I'm also speaking on behalf of the collection, the Centrale Custodie, who is very happy that we can have Nick Hopwood here to talk about embryos and collections. Anyway, to tell you a bit more about his work, he did find out the molecular basis for mesoderm development of mesoderm genes. He did the groundwork for mesoderm formation in Xenopus at a time in the 1980s when you couldn't just order things from the toolbox from industry. You had to do it yourself, so he's really a bench worker, and he accomplished this with great success because his PhD thesis work was published in papers like Nature and Cell at a time when he has already moved on to Imperial College. John Gurdon is in Cambridge, and Nick comes from Cambridge, came today from Cambridge, but that was all done in Cambridge, the PhD work, but then he went to London to Imperial College to do a master's thesis in history. And during that time, during these 2 years at the end of the 1890s, he published this work on the molecular biology that he did with John Gurdon. And from then on, he turned into a historian, but with the meticulous method of a molecular biologist. And I'm very glad that we can hear something objective about fraud, evolution, and images. And with that, I think it's enough time that I've spent, and I would like to ask Nick to give out his talk now, please.
Well, thank you very much indeed for that generous introduction, and thank you for this invitation. I'm extremely honoured to be here. I've studied past meetings of this society. I never thought that I would ever address one. So it really is a great honour and a pleasure to be here. I want to start with the question that I'm interested in this book that I've just written about Haeckel's embryos. If we open a science textbook or call up a web page, we see many new images, but some old ones. So this one here is credited to a textbook from 1901. The world is flooded with images, but most of them are soon forgotten. How do a few become textbook illustrations or even icons? We know something about the afterlives of artworks. Why is the Mona Lisa, La Gioconda, the most famous masterpiece in the world? But we know much less for science, where there's also a stronger expectation that images will be continually replaced. To find out more, I've focused on a single family of images with a quite extraordinary history, and these are Haeckel's Embryos, which, as is of course well known in Germany, were first published in books by the German Darwin that take an evolutionist system to the reading public for the first time. The Natürliche Schöpfungsgeschichte and the Anthropogenie. For Haeckel, comparative embryology was crucial evidence of common descent, but no really vivid, really striking images had been published at this time in the 1860s. So he designed some, and they all have that typical structure of rows for developmental stages and columns for vertebrate species, here for mammals, culminating in human development. We mainly see initial similarity. That's pointing to common descent. We can also, if we look more carefully, see some instantiations of Haeckel's famous dictum, ontogeny recapitulates phylogeny. You could say that the first row corresponds to the stage of the jawless fish. But the main thing is the similarity and then the divergence. These pictures powerfully line up the images for comparison, far more powerfully than ever before, and they're soon criticized. Haeckel is accused by colleagues of various misdemeanors. You probably know that he's charged with having a single woodblock printed 3 times to represent members of 3 different vertebrate classes. He corrects that in the 2nd edition of the Schöpfungsgeschichte, and that series has no future, and I won't talk about it more. The charge against the plates of the kind that I've just shown is that he has drawn them tendentiously to make the embryos look more similar than they really are. This becomes a public dispute in Germany in the mid-1870s, and quite a big scandal on the eve of the First World War, when it's also reported internationally at a time when the United States is taken over from Germany as the world center of science. So here you can see in the New York Times a rather garbled account of this controversy. In spite of that, the pictures go on to become the standard illustrations of comparative evolutionary embryology, especially in American high schools and colleges through the 20th century. Until, that is, the 3rd phase of controversy, which starts in 1997. Embryologists have become interested in evolution again, and one of them, in ignorance of all of this history, accuses Haeckel of fraud. That is picked up by the creationist advocates of so-called intelligent design. Now, what you can see here is one of them in a still from an early YouTube video showing a skeptic that, yes, Haeckel's embryos really are in the textbooks, and so the argument goes, Darwinists have been lying to us all these years. Publishers and authors take the figures out, and if at that time you put Haeckel's embryos into Google, you would very quickly go to one of these sites like darwinismrefuted.com. Now, I don't need to tell this audience that Darwinism should not be at stake here. Molecular homologies make the case for evolution far better than Haeckel ever could and better than his pictures do. Today, I think his pictures have something to teach, but it's more about how pictures succeed and fail. And that's what I'm really interested in here. But first, we need to get past a more obvious question, because when people hear that I'm working on this topic, they often say, well, did he really forge them then? And I can answer that question in a nutshell, compared with standard practice of the time. Haeckel's drawing was at least unconventional, perhaps even reckless, but there was no intent to deceive, and he would have had very little to gain from that either. But the question is too individualistic, even to grasp the forgery issue. So this is my question, which I'm suggesting is more interesting. How do scientific images succeed? How do they become taken for granted? How do they sometimes cause trouble? I'm not the first to ask it, but I think that my book is the most comprehensive answer for a scientific image. But you might be thinking, why write a whole book about these popular pictures that Haeckel drew on the back of an envelope in 5 minutes? Well, because they're strategic in the first place. They mediated between teaching in the universities, research and media science during just those decades when scientific images are taken to a mass audience for the very first time. And they're published in books that engage the most expert comparative embryologists, members of this society, who responded by producing the standard images that are still used in developmental biology today. But at the same time, they enthralled school children who see Haeckel's evolutionism as solving the mystery of life. So they're strategic, but they're also exemplary, because over time they played so many different roles. You might want to think, as I'm talking, about images that you might know better and see if parts of the story might apply to them. But we can only see all of this if, instead of focusing on Haeckel's psychology and that one moment of drawing, we look at a longer history of copying, of repetition, and of circulation. So what I've tried to do is to start really with the preconditions for these pictures in the rise of developmental series in embryology from around 1800, and of an audience for popular science through the middle of the 19th century. And then to look at the design of the grid and the first accusation of forgery, or something approaching forgery. And then to follow the copying of the pictures and the repetition of the charges through 3 big controversies, after the first 2 of which the pictures are very widely copied. How could alleged forgeries have been so successful? That's the question the book answers by looking at the copying of the pictures, the repetition of the charges, and how pictures and charges circulated, usually independently, but sometimes coming together in ways that exploded into big national or international controversies. So what I want to do in the rest of the talk is just give you some highlights of that story and a few key points. So let's start in the 1860s, when the Jena zoologist Haeckel is beginning a career as a champion of Darwinism. His strongest evidence is comparative embryology, he believes, and some resemblance of human embryos to those of other vertebrates. That's not controversial among embryologists. But there are no vivid pictures. I mean, some of the best that existed before Haeckel's grids are these by Darwin's bulldog, Thomas Henry Huxley. So, a series for the dog leading up to what Huxley calls a very young puppy, so really a very young puppy indeed, and a human series, but they're not easy for a layperson to recognize as the same. They're on different pages of the book. Haeckel wants something a lot stronger for his natural history of creation. In Haeckel's archive in Jena, the Ernst Haeckel House, I found the original drawings for the first grid. They come as pairs. It's not a grid initially. So dog and human at an earlier stage, and then dog, human, turtle and chick at a later one. In private comments to a colleague in early 1869, Haeckel explained effectively that he'd drawn types. He had synthesized from illustrations in the literature and from specimens in his possession. And he had made the drawings comparable by drawing, as Huxley didn't, at the same size, in the same position, and in the same style. You also notice, and Haeckel didn't discuss this, that style is unusually dramatic and schematic at the same time, especially these googly eyes of the human and dog here. Haeckel is transferring some of the tricks of the popular lecturer to his book. This is the printed lithograph, rather faithful to Haeckel's drawings, and surrounded by Haeckel with provocative liberal rhetoric. Even those aristocrats, he thunders, who imagine that there is blue blood flowing in their veins, even they, for the first 2 months of development, are indistinguishable from dogs. This lithograph in the first edition is still structured in pairs. So that grid design that's so powerful and so important for the success of the pictures is not imported ready-made from some other field. It's only created in the second edition using the opportunity of all of the figure captions moving to the end of the book. And that is what makes this first arrangement as a grid with now 2 stages across the page and the beginnings of columns down it. Now, I hardly need to tell this audience, just to make one of these images is a great deal of work, from rare, tiny, initially nondescript or differently interpreted material. Making and then coordinating series for different species is more challenging, especially at this time when relatively few specimens are known. And the way that Haeckel does it is soon challenged. He's charged first in 1869 by the Swiss paleontologist Ludwig Rüthemeyer, who himself is a cautious evolutionist. Haeckel was certainly an incautious evolutionist. But Rüthemeyer, like all of the leading embryologists of the day, was hostile to Haeckel's aggressive, speculative Darwinism. So the sort of objections I'm talking about, you can see comparing Haeckel's dog and human to the illustrations that Rüthemeyer and others say Haeckel has miscopied. So the charge is that the brain of this dog has expanded to make it brainier in Haeckel's version, and the tail of the human embryo has turned into this huge upward curling structure. These are the sorts of objections. But sympathetic professors who teach embryology as anatomists or zoologists in the German universities, those who are sympathetic to Haeckel mostly think that he's telling them something that they already know about embryonic similarity, or perhaps that they should remember. Charles Darwin wrote in his copy of Haeckel's book, "I must know embryology." Haeckel is also much more controversial for other things, for his speculative evolutionary trees that include human beings, And so the low circulation charges against his embryo drawings are not a big issue for the first 6 years. But then he comes out with the second big book, the Anthropogenie, which is all about embryology, as is announced in this frontispiece on the development of the face, where you can see from very similar beginnings the development of the Greek god Zeus, a ram, a bat, and a cat. So at the height of the middle-class reception of Darwinism, Haeckel is taking the most important disciplinary struggle in biology. Should embryos and life more generally be understood in terms of evolution, of phylogeny, or instead in terms of physiology? And he is aligning that in this book with the major confrontation between the German state and the Catholic Church. All of that liberal rhetoric ramped up to an even higher level. And he expands this grid. This is the full double plate, of which I just showed one at the start. So the other classes on this other plate. Now this seems very unhelpful to leading scientists in Berlin who are trying to negotiate with Bismarck's government the freedom to research in the new German Empire, while agreeing limits that will avoid trouble over religion and politics. Haeckel charges in with his provocative speculations, arguing that evolution should be taught in the schools and so on. And that general concern about limits extends also to his schematic drawings. They seem like the visual equivalent of dangerous speculation. But many readers actually have a more basic problem. The book's too difficult. It's too difficult for those Haeckel disparages as the so-called educated, die sogenannten Gebildeten. Those products of the classical grammar schools who don't believe that humans come from eggs. And if you show them pictures like this, they turn up their noses in disgust. This is a cartoon by an artist for the Bavarian Punch, the Fliegende Blätter, from a spoof of Haeckel's Anthropogenie, which turns that large book into a collection of student drinking songs, which Haeckel actually quite liked because they communicate quite a lot of his ideas. And here Haeckel is represented lecturing in front of embryological wall charts, and the poor listener has had his mind literally blown by all of the new terminology and these complicated forms, and he's running as fast as he can to the pub, perhaps the Golden Star, for a drink. So this is the context in which expert opponents now speak out against Haeckel. The key figure is Wilhelm His, the Swiss professor of anatomy in Leipzig, and of course a co-founder of this society. Unfortunately for Haeckel, His is committed in work that he begins on the chick and will later do on human embryos to anatomical exactitude, making wax models from serial sections for the first time, and also to a mechanical physiological approach. How does one stage give rise to the next in the here and now? Evolution for His is not an explanation. In the course of attacking Haeckel, His amplifies and expands his former colleague Rutemeyer's charges in a book for a wider audience. And that makes this dispute among evolutionists give ammunition to their enemies, so that many theologians and others now pick up these charges. Haeckel has an answer, of course. He says, these are schematics, like we use in teaching every day. Of course they represent my views, Did you expect me to stop thinking when I drew them? And Haeckel's many supporters largely accept that explanation. In 1878, with the political shift to the right in the German Empire, the debate over Darwinism is largely closed down for a decade or so. But there's no closure. The sides are much too far apart. So opposed interpretations of Haeckel's drawings are cultivated in the different milieux. Some people are very angry with him for, as it seems, discrediting Darwinism. Others try and separate the healthy core, as they see it, from Haeckel's excesses. This is from that same spoof, playing on the frontispiece to the anthropogeny, on the development of the face, with this pseudo-developmental series culminating in the German Mische, the national stereotype. So Haeckel has caused a lot of trouble for a lot of people. For hostile anatomists in particular, he has destabilized the representation of human embryos for a very large audience, and they try to restabilize embryo images. Wilhelm Hiss, in particular, regains the initiative by inventing so-called Normentafeln, or normal plates, the ancestors of the normal stages that developmental biologists still use today. So, in case you're thinking Haeckel's pictures are popular pictures that have nothing to do with research science, the most authoritative standards are produced in reaction against them. But anatomists can't stop Haeckel's pictures circulating, especially as copies. They're copied initially into other books about evolution from the early 1870s, and when an author has them copied, that means that either they reject the forgery charges or they don't know about them. Significantly, although they are used in several important evolutionary works and copied into encyclopedias, no German professor uses these pictures for many decades, and even some of Haeckel's close allies in Germany avoid them. The copying also selects a canonical form. I mean, we tend to think of Haeckel's embryos or Haeckel's Embryonenbilder as that double spread from the anthropogeny. But if you look earlier, there are much more various copies from Schöpfungsgeschichte and Anthropogeny, and you can arrange them on a spectrum, but I would identify two limit scenarios. On the one hand, authors treat Haeckel's grids as a very authoritative source of figures that they can copy, often with other unimpeachable illustrations, to fit simpler and cheaper books. And it's cheaper to just use a fewer of them when they have to be re-engraved. At the opposite extreme, if you're expert enough, then you can take Haeckel's grid and replace every single figure with a more accurate drawing. But those redrawn grids don't take off, so that by the early 20th century, most books are reproducing the whole grid, which is now much easier with photomechanical methods, from a pretty uncontroversial secondary source. So all of this time, the pictures have been copied, but they've also been involved in controversies in which the forgery charges are continually repeated. After the debate in the 1870s, Darwinism is effectively banned from German schools. But you know, kids, this adds to the appeal of these forbidden fruit. And so school children are often reading Haeckel under the desk, and they might be caught by the religion teacher especially and told it's all forgeries, it's all lies. They're flashpoints in battles across the generations and between different milieux. Big controversy That comes with Haeckel's role in creating a mass audience for science. This cartoon shows him visiting Berlin in 1905 to give big public lectures. He's holding the Welträtsel, his riddles of the universe, that primer of scientific anti-clericalism, that sells over 10 times as many as his earlier books. You can see that sparks from his torch of enlightenment are threatening the newly built cathedral. The real threat is of atheism, working class atheism, to the alliance of throne and altar. So, in 1908, right-wing populists level new charges against pictures in pamphlets derived from those lectures. This reaches the front pages. It's much larger controversy than in the 1870s, but Haeckel is saved because his colleagues rally round many of them, the figurehead of German Darwinism, without actually condoning his drawings. After his death in 1909, Haeckel's reputation declines further, including because his approach to embryology is largely rejected. The physiologists really win. But American textbooks save the pictures. And that's how the most heavily criticized pictures in the history of science become some of the most widely used. Now, it's not news that textbooks recycle images as well as errors, but how do we explain that in particular cases? It helps to have patterns. For example, they are introduced into the United States earlier because, although the charges were reported, as I showed, they're less well known, and there's more teaching of elementary evolution-based biology. There are general conditions for the recycling of the pictures. Textbooks expand, their production becomes more bureaucratic. But there are also more specific ones that explain how they can survive the modern evolutionary synthesis and the curriculum modernizations of the 1960s. One important contributor is that the legacy of comparative embryology is very confused. People are very unclear what they should think about recapitulation especially. Use of the pictures is very stereotyped, and they're protected because they're often not credited to Haeckel, they're credited to a secondary source. So it's quite common for the pictures to appear on a page that explains that Haeckel is wrong, we don't believe in recapitulation anymore, and here are the pictures that prove it. We can only appreciate that if we see the pictures not as a readout of the recapitulation theory, as is usually done, but appreciate how open they are. And this openness is part of the contributor to their success. But all this time, there's been one whole class of book from which the pictures are absent. Books devoted to embryology. They only enter those books in the early 1980s. They come from general works into textbooks and advanced reviews, like this one by Richard Ellenson. So these are Haeckel's figures just turned on their side, and Ellenson is making the point that there's this stage of similarity and then divergence, but there's also a lot of difference early on, and so there's a convergence on this, what comes to be called the phylotypic stage, the so-called hourglass model. And that use in developmental biology sets the stage for the rediscovery of the forgery charges. The London developmental biologist Michael Richardson, as I say, in ignorance of all of this history, opposes the notion of the phylotypic stage. He argues that natural selection is acting equally on all stages, and alleges that Haeckel has committed forgery. Richardson provides his own photographs that are supposed to show differences, and of course designed to do that. This is picked up by creationists who force those publishers and biologists who haven't already removed the pictures to take them out. But like in many acts of iconoclasm, it doesn't serve creationists just to get rid of the pictures. The aim is to turn them into negative icons. And so, ironically, Haeckel's pictures are now, in the age of the internet taking off, reproduced more widely than ever before. And so, it was possible for creationists to go on websites like this and buy one of Haeckel's embryos along with other so-called icons of evolution on t-shirts or beer mugs or calendars. And I must say, when I finished the first draft of the book, I thought this is where the story was going to end, with their use only by creationists or historians of science like me. I should have known better, having followed all the twists and turns up to that point, because at the end of 2010, the pictures occupied the most sought-after space in all science publishing, the cover of Nature. But in an unusual form. This is a mosaic made by sampling a database of gene expression patterns in Drosophila embryos. And inside there are papers from 2 German laboratories that confirm the phylotypic stage, that genes expressed then are both older and more conserved. And that mosaic became the prototype for software that enabled scientists to generate mosaics from their own pictures and so perhaps get their picture on the cover of their favourite journal. So Haeckel's images, they haven't just hung around. They are still involved in innovation after 140 years. That's what I think of as the shock of the copy. So, if I could just draw a few conclusions. I've tried to show that, of course, the structure of those grids is very important in making the pictures so persuasive, but it's also important that they're open, that they can be read and used by people who disagree with Haeckel about just exactly how evolution occurs. I've suggested that copying, which we tend to think of as the very definition of the unoriginal, the derivative, that it can actually be creative, sometimes in problematic ways. Haeckel was accused of miscopying from the literature, but also in generating that grid and then in selecting the canonical form. And of course, it can be, and in this case was, highly contested. I've talked less about how those big controversies blew up, but it's about when the copying of the images and the repetition of the forgery charges intersected. And I don't know about you, but I wouldn't want to bet that Haeckel's pictures don't have a long life still in front of them, and that a big controversy won't one day blow up again. Thank you very much for listening.